going to go through this Unit 6 lab, this queue. If you want to do it on your own, you're welcome to do so. It's very similar to the stack. But this is our first time using pointers, and you seem to have a little difficult time with it in class, so I thought maybe we could do this one together and it will save you some heartache. So go ahead and copy all of these function definitions and download this testq.cpp. That's going to be our main file. Build your project out of it. I've already got my main included, and I've already included a q.h. And then go ahead and paste these function prototypes in. We're going to be building, first we'll start off just building a skeleton code, meaning all the functions are there and it will compile, but it won't actually do what it's supposed to do, and then we'll go through a little bit slower on the logic. So paste those in here. Our OStream operator, our extraction operator, that has to be a friend function, F-R-I-E-N-D, so put the keyword friend on the beginning of that. Now let's go ahead and put in our skeleton code. So we're going to go back to our q.h and paste these functions in again, only this time we'll implement them. I've got my two queues up here, so if you don't have them you can type them in. If not, do what I do and delete them. And instead of semicolons, we're going to put the opening and closing squiggly brackets. Now even though there's no code in there, it will compile because it thinks it's implemented because those brackets are there. And that's why we call it kind of a skeleton program, because it doesn't really do what it's supposed to do, but it compiles and runs. Okay, now that that's in, we do have to add the scope resolution operator. So go ahead and copy that and paste that in for each of your methods, with the exception of your extraction operator. Okay, now any non-void, this is non-void because it's bool, we have to return a value. So it doesn't matter what you return on a skeleton program. I'm just going to say return false, F-A-L-S-E. I can't talk and type at the same time. This one has to return something, so let's just do an empty string. And this one has to return our out anyway, so let's just go ahead and put that in. And then later on we'll go through and make it beautiful by putting out in a couple of times. Okay, this should now compile and it should run, even though it's going to say, hey, checking an empty queue, it didn't, the value is, because we put in just random garbage, right? Okay, so let's go through what a queue does and some of the properties of the queue, and then we'll come back to this and code it exactly how we discuss it, I guess. And one of these has my logic. There it is. Okay, so queue. Talked a little bit about in class, a queue adds items to the end of the queue and items are removed from the front. So for example, a queue at Disneyland, waiting in line at Disneyland, you get into the queue. If we add Alex to our queue at Disneyland, little Alex comes walking in and there he is at the front of the line. Okay, now it's Bob. Bob's going to come in behind him and he gets added to the end of the queue, the end of the line, right? Now if we add someone else, Carrie's going to get added to the end of the line. At this point, if we remove from our line, that means it's Alex's turn to go on the Matterhorn, and he gets pulled off of the queue from the front. Then we can add Dana, and let's remove someone. Now it's Bob's turn to go on the ride of his choice, or whatever ride they're in line. I guess they're in the Matterhorn because I said that already. Alright, so there is kind of the logic of the queue. And you've seen queues before. If you ever printed something, it'll sometimes say this document is being sent over to the printer queue. And anytime a printer receives information, it just handles those print jobs in the order that it receives it. But it has to be stored somewhere, so it's stored on a queue data structure. Now because we are accessing from the front and the back, unlike the stack we were just accessing from the top, we were adding and removing from the top, but since we're both keeping track of the front and the back, we're going to have two pointers instead of one. We're going to have one for the front of the line and one for the back of the line. Now, just like a struct, a stack, we're still going to have a node, and we define that just with a struct. So we'll say struct node, and we're storing names or something like that, so we'll say string data. If we were storing ints, we could say int data, or whatever type of data we wanted to store. And then this is the key to make it work. We do need a pointer to the next person in line, whoever it is, and it could be pointing to nothing. So I'm going to represent a node with this little rectangle, and pointers I'm going to represent with arrows to kind of keep track. So this one is not pointing anywhere, so there's no arrow involved, so I just have it as next. The name is next and the data is data. Alright, so if we have an empty queue, that means the head is pointing nowhere and the tail is pointing nowhere. Okay, let's code just that far. Alright, so let's go back, and that means we need to go to our .h file, and we have the public and the private. We're going to set our pointers in the private section. We always try and keep our data slightly protected. So we need to create a pointer to a node. Well, that means we need a node. So come up here to the top of the program, and we're going to say struct node. And it really doesn't matter what you call the node, but node is kind of a standard word they use for this particular struct. So let's keep it consistent with what you'll find in other places. And I'm going to do a string for the data, and I'm going to do a node when it's a pointer to the next person in line. Alright, so there's my data. Let's make this bigger so you can actually see it. Sorry I didn't do that earlier. You're probably like killing me saying, hey, this is too tiny. Maybe it's just me because I'm old. Alright, so now I'm going to create a node to the front of the stack, because that's what we need, and we need a node to the back of this not stack queue. There we go. Now we have our two pointers, so we can do our empty queue. Go to your constructor. This is our constructor queue : queue, and we're going to set both of those to null pointer. Alright, so far so good. Let's compile this and run it, and it should pass a test case or two. No, I don't have any test cases for an empty stack. Darn it, I should have. Okay. Okay, next thing we're going to do is let's go on with our little discussion now. So empty queue, we've talked about that. Now when we're ready to add to an item, here we'll say add one. All we do is we set the head and the tail pointing to whatever it is we happen to add. Now these are pointers, they're not nodes, so I'm representing them with arrows instead of with a little square thing. So head is pointing to this node and tail is pointing to this node because I've now added one item into our queue. And anytime you add to the queue, if there's only one item in it, you are both the first and the last person in line if you're the only person in line. Okay, now let's go on just a little bit, and we're going to add another item. The second person in line in the queue. So we're going to add two. Okay, the first thing we have to do is create a new node. So here I want to create a new node called to add, something like that, and I do that in code just by declaring a pointer and instantiating it. This new keyword means I've now allocated some new space for this information. I haven't stored anything there, it's empty, but I've allocated the space, and so I've got a rectangle here now. Okay, next I want to populate this. I've added two, so I want to put two here, and I want to set this to null pointer. So there it is. I've set my data to whatever my data is, and I've set the next value of this to null pointer. Okay, now I'm still not quite done. I've got this pointer, but if you look, my tail is still pointing here, and this is not actually in this list. Nothing is linking to it. So I'm going to add a couple more things. Whoa, I lost my animation. Where'd it go? It's going to come back. There we go. I need to add this pointer in. So I'm setting the tail. Did I call it the tail? We called it back, didn't we? Let's change this really quick. We called it back, and we'll get rid of those darn animations because they shouldn't be in this one. Okay, play that again. How do I present? Okay. Okay, so I've added my pointer in, and that's done right here with this line of code. I say back What am I setting? I'm setting this pointer. It was null pointer. Now I need to put it so it's pointing somewhere. Where am I pointing it? Well, to my new node. So I've said back arrow next equals to add, and that will add this new pointer into our list. Now I'm not quite done, because look where our back is still pointing. And I'll bet I'll have to change it on the next slide. Yes, I have those darn animations in here again. I forgot to copied and pasted slides. Come on. There it is. Okay, so all I'm doing is I'm setting the back to point to the end of the list. So I say back equals to add. So I'm setting my back to this value, wherever this happens to be pointing to, is now where back is pointing to. Okay, we've seen what that's like in logic. Now let's code that. Here we go. Here's our to add. We're going to go in and we're going to create a new pointer. So I can do this using the auto keyword, or I can use the star keyword, and I'm going to call it to add just because that way it's consistent. Set it equal to a new node. I do have to set the information in. Remember, we have to set the to and the null pointer. So I'm going to say to add arrow data equals whatever this information is that I'm being sent. So in this case, it's data. I need to set the next value, so it's null pointer. Now, if I am adding to the front of the list, meaning if front equals null pointer, that means there's nothing in the list. If there's nothing in the list and I add one item, I know that this is the one item, and I have to set my front equal to add, and I have to set my back equal to add, because there's only one item in the list, so the front and the back are pointing to the same place. Anything else, and if you remember, what we need to do is let's go back to our little picture of it. Back was pointing here. I need to set this next value to point to here, and I need to set back to point to here. Two things. So first I have to do the next value. So I'm going to say back next equals to add. All right. So let's show you how that works. So back was pointing here, and I set the next value of back to point to our new pointer. Last thing I need to do is update where the back of the list is. Back is no longer at the back. So I'll say back equals to add. So anytime you have back equals, it's changing where the pointer is pointing. Anytime you have back arrow next, it's changing where the next value is of that particular pointer that it's pointing to, if that makes sense. Okay, this should now slightly work. And if I look, am I passing anything? No, I'm not passing anything. There's a few more. Checking an empty queue. Oh, I haven't coded that one yet. That one's an easy one. Okay, the rest of this program is almost exactly like the stack. All right, we can go through it really quick. Let's make ourselves feel better about ourselves. Let's do this is empty. And we'll say there's a couple ways of doing it. Let me show you both ways, whichever way you understand. You can do an if statement that says if front equals null pointer, then return true that my stack is empty. Anything else is going to be a return false. Okay, that's a long way of doing it. This works and it's easier to understand. There's a shorter way though. You can actually consolidate this and just return this statement, because if this statement is true, it's going to return true. If this statement is false, it's going to return false. So that's kind of a little shortcut, same shortcut that we got on the stack. Next we're going to do peek, and peek is exactly like the stack as well. All we have to do is find the front of the stack and see what the data is. So return, if I could spell return, front, no, what's that? Data? Data. There we go. That should do it. Okay. Let's do our remove. And before we do the remove, let's go through and explain what's going on. Okay, so I'm going back to our presentation. Hope I don't have those extra and get through this animation. Okay, remove. Went too far. No, I didn't. Okay, here I have my back. My back is pointing to this one, and if I call remove, this is the one I want to remove. All right? No, I want to remove the front, don't I? Because it's a Q. Excuse me. Okay, so first thing we're going to do is we're going to put in an if statement, because if they try and call remove and there's nothing in the line, it's going to crash our program, and we just don't want that to happen. So we're going to do an if statement that says if it's not empty, then go ahead and allow them to remove. So then we're going to create a temp pointer. That way it points to, and it's going to point to wherever the head is pointing to. That way we can move the head pointer and still deallocate our space. So that kind of looks like this: auto temp equals front, or I could say node star temp equals front. Both ways will work. Next thing I want to do, and I want to have this temp here, because if I move my head over here, which I eventually want to do, then I won't have any access to get back to this head pointer, so I can't actually delete it. Alright, so now, that's weird that that keeps doing that. Okay, next line of code is I move my head pointer to point to this value over here. And I do that, and this is a weird line of code. It's saying front equals front of next. Front is here. Front of next is pointing here. So I'm setting front, and I called it front and not head, didn't I? Let's change that. Front equals front of next. It's now pointing to this point over here. Okay, the last thing I want to do is, now that my head is pointing to the right spot, technically at this point it would work. However, we have a memory leak because we have this node that's allocated and still sitting out there. We just don't have any way of accessing to it. And that's why we created this temp variable, so we can access this particular node. So we'll say delete temp. And what that will do is that will just deallocate that space, so now it's gone. And now I have head and back pointing to the correct nodes. Okay, so now that we've got that logic done, let's code our remove function. So remove, if you remember, first we have to see if our stack has anything in it to remove. If our stack is not empty, and we can do this is empty because we've already coded our is empty up here. Okay, so if it's not empty, the first thing I'm going to do is create that temp pointer. That way we still have access to it once we've moved our front pointer. And then I'm going to move the front pointer to the second point in the list. Front equals front arrow next. Then I'm going to delete that temp so I can deallocate that space. Okay, remove, that is done. And if you look, this is exactly the same code in the stack because we're deleting, only it says top instead of front. Okay, peek is done. What else do we still have to do? We should probably do our extraction operator and our destructor up here. Let's do the destructor. That one's pretty easy because it's exactly the same as the stack. So while the stack is not empty, then we'll just keep removing items from the stack. Now, as soon as the stack, that's it. We're done. Okay, so let's do this last method and we'll call it a day. Compile and make sure it works. Okay, so on this one, what I want to do is I want to iterate through the list, and this is exactly like the queue as well, or the stack as well. So I'm going to say auto cur equals front. The only problem is since this is a friend function and not an actual method, I can't just say front because I don't have access to the private variables directly. I have to use my I'm going to call it Q instead of S, whatever object I'm sent. So I'm going to say Q dot front. And then I'm going to iterate through the loop while cur is not equal to null pointer. So I'm hoping that as soon as its cur is going to keep going through to each node, and as soon as the next value becomes null, then cur becomes null and it will fall out of my loop. So I want to add just the data. So I'm going to say out arrow arrow cur data, and then maybe put a space after it just so I can see it. Now to move to the next node, so if cur is front, this will print out the data that's in the front node. The next thing I'm going to do is I'm going to move my pointer to the next thing by saying cur, and I'm assigning where it is. It's going to point to a new node. So I'm just going to say equals. I'm not going to say cur next or anything. So cur equals, and where do I want to set it? The next value. Well, that would be cur next. So cur equals cur next. It will take us and point to the second node, then the third node, then the fourth node. Eventually it'll get to the last node, and it will, and if the last node cur next is null pointer, it will set cur equal to null pointer, and that means it will fall out of this loop. Then I return it, and that should be it. Okay, let's compile this and see if there's any errors that I didn't think about. Oh yeah, I'm missing a semicolon instead of a bracket. I forgot to change that because we originally had that as an if statement. What am I missing here? Oh yeah. Anyone know? Cur was not declared. This is a spelling error. No. Auto cur. Oh, single cur is not defined. There we go. Did you guys get that same error? Okay, we're down to 1. No match for the operator. Not cur data. Yeah, cur data. Listen. I'm going to pause for a sec while I work this one out. Hold on. Well, hopefully yours works at this point. I did find my issue. I don't think you guys are going to have this same issue. This is the weirdest thing, but mine just doesn't like this space here for some reason. If I compile that, it works just fine. So I'm going to kind of trick the system by creating a space out of a string and then concatenating that on random. I don't know why it's doing that. That's really weird. I've never seen it do that before. So if you know, let me know. But then there it comes. It passes all of the test cases. If you look in main, it's adding 1, 2, 3, 4. If it does a cout statement, there's my 1, 2, 3, 4. It's all getting printed to the stack. It checks to see if it's empty. It checks to see if the front one is in order and stuff like that. So good job on this one, and hopefully this was less painful doing it together than it was doing on your own, and we will see you in class.